Hello and welcome dear students. I am Nandlal Singh, your mathematics mentor, Bhagavad VIII chapter. Students, today I am going to explore exponent in detail. First, you can see that exponent can be expressed as two types, positive exponent and negative exponent. Positive exponent show a bigger value. You can say that I have written over there 2 raised to the power 4. Now after break it, we get 16 plus 16 is a quantity, and now we are expressed 2 to the power minus 4. After break I have get 1 by 16. You can see that 1 by 16 show a smaller quantity and 16 show greater quantity. So you can compare that a negative exponent always show a smaller value rather than a positive exponent. Now what are the use of exponent in expand a large number? Exponent decrease as we move toward the right on the right side. You can see that I have written over there 12,678. When we move left to right of the number, you can see that 1, 2, 6, 7, 8. We move like that. So exponent will be decreased simultaneously. In the case of decimals, it is also show the same behavior. But after the decimals part, we are going to raise the power in minus form. You can see that 3, 2, 1, 0, and after 0 minus 1 and minus 2. It shows the decimal expansions of a exponential form of a bigger quantities. After that, we are going to talk about laws of exponent. For any integers a and b, I can write a raised to the power m into a raised to the power n. In the form of multiplication, two exponential numbers are there and their base will be same. Then we equate the base and add up the power. Similarly, in the case of division, we are going to subtract the exponent. And the third case, a raised to the power m and that power raised to the power n, that we are going to multiply this exponent. In the third case, if two exponential number have same exponent but different bases, we are going to multiply them and put the common exponent. In the division case, it is also true, and any number raised to the power 0, its value comes to be 1. Now you can see that the law. Now I am going to show some example based on this property. First, powers of the same base. In the case of multiplication and division, you can see that I have written over there two exponential form which have same base but different exponent. In that particular case, I am going to add up the power with common base. Similarly, in case also, you can see that minus 3 raised to the power 2 into minus 3 raised to the power minus 2. So minus 3 raised to the power minus 2 plus minus 2. Why? Because it is come in the case of multiplication. But in the division, we are going to subtract them. You can see clearly that here I am going to use subtraction because you have already read the laws just now. You can see that here in the case of division, I have subtracted the exponent. Now, the second example is power with the same exponent. If in that case, bases are different but the powers are equal. Now we are going to multiply the bases with the common exponent. So you can see that here 6 raised to the power minus 3, I can write it 1 by 6 to the power 3, and then we break like that, 6 into 6 into 6. Now in the case of division, it is also true, we are going to put common exponent in the division form. You can see that here 4 raised to the power minus 2 and 2 raised to the power minus 2. Now 4 is divided by 2, and put the common exponent like that. I am going to write like that also. 2 raised to the power 2 is equal to 1 by 2 into 1 by 2, and then you can multiply. Now we are going to discuss some questions. Here are questions we are going to evaluate 1 by 2 raised to the power minus 5. Now minus 5 can be distributed over both the number, and we can write like that. Now 1 by minus 5, I can write 1 by 5 raised to the power 5. So negative number comes to be positive. Similarly, 2 to raised to the power minus 5, we can write 1 by 2 to the power 5. Now 2 to the power 5 come into the numerator, and the final answer will be 2 to the power 5, that is equal to 32, and 1 raised to the power 5, that is 1. The final answer will be 32. Similarly, you can see that here the value we are going to evaluate, in this case the exponential forms have negative exponent. Now we are going to change the fractions over there, so the exponent becomes to be positive, and you can see that simply I am going to add this number, and we have get the answer simply. So it is very simple for you, this chapter. Now this is the questions which is very important. Find the value of m for which of the following. You can see that there is a questions, and I am going to use exponential law to determine the value of n. So here 5 raised to the power m divided by 5 raised to the power minus 3 is equal to 5 raised to the power 5. Now if the bases are same and division forms are there, we are going to subtract the exponent. Now it will be look like that. So two exponential form are there which have the common base, so both have equal. So if bases are equal, then exponents are also equal, because things are also equal. So in that particular case, we have get the answer m is equal to 2. So this is the second lecture on the topic exponent. Now we are going to meet in next video with some more properties of exponent. Thank you.